lesson number 5.2, that is about the circular motion. In this topic, uh, we are talking about the force. Previously, we did talk about the acceleration and velocity. So, before I move forward, I just want a quick review because I want you guys to understand each and everything well. For that purpose, let me start with the first thing. What is that first thing? Whenever we are concerned with the circular motion, let's say this is an object. This object is moving along circular path. So when this object is moving along circular path, what we know is the first thing that I just want to remember you that what we know. The first thing that we know is that the object when it moves in a circular path of radius, let's say the radius of the circular path is r. So when this moves in a circular path, we know that we are very well aware the velocity is always tangential, and this tangential velocity is along the tangent to the point. This is first thing that we know. Secondly, when object keep on rotating, its velocity keep on changing the direction. When it is at the second point, its velocity is to the left. When at third point, velocity downward. When at fourth point, its velocity is to the right. So you can see at every point, its tangential velocity is changing the direction. So we say that as velocity change the direction, velocity change direction, so we can say acceleration is produced. So this velocity changes the direction means acceleration is in the object. This acceleration is named as centripetal acceleration, or sometime we use the radial acceleration word here because this is along the radius toward the center, and we found that it was equal to v squared over r. Mathematically, this relation we studied in very first lesson. This is this. So what is the direction of this velocity? To know the direction of this velocity, we said that this velocity, this acceleration, sorry, the direction of the acceleration is along the radius toward the center of the circle, if this is the center. Now, from the Newton's second law, we also know one more thing. What Newton told us from the second law, Newton said that net force on an object is equal to m times acceleration. And if you talk about an object moving in a circle, so I gave you the example of something attached to the string, and I am whirling it, I am trying to spin it. When I am doing this, my hand provide the force that keep the object in the circle. So if that force is to keep the object around the circle, so I will say that this force according to Newton law is used to keep the object in circle. So this force keep object in circle. So this force that keep object in circle or circular path is named as centripetal force or the radial force. So this will be equal to MAC, and we did talk about this. So mathematically, if we can also derive this, if you substitute the value of AC from equation number 1, it will be mv squared over r. This was your second expression that we derived last week. Now, the question comes, arises, where will be the direction of force? It is Newton's second law that told us that force is always directed toward acceleration. Force is directed toward acceleration. So when we talk about force, it is always toward acceleration. So if AC is towards center, so force FC, the centripetal force or the radial force, will also be toward the center of the circle. So if you want the relation between force and velocity, they are perpendicular. Acceleration and velocity, you can say force and acceleration both are along the same line, they are parallel. If you talk about force and velocity, they are, you can say they are perpendicular. If you need acceleration and velocity, these are also perpendicular, because this angle is 90 degree between velocity and acceleration, or velocity and force. So these are two important relations that we developed in last 2 weeks, and these two relations we have to use throughout this lesson or throughout this chapter. There was one more thing: when object move in a circular path, so we say that it completes its revolution. So time it takes to complete revolution was period. Number of revolutions in 1 second was frequency. So if you want to find velocity by using the period, we can also use a third relation, that was v is equal to 2 pi r times t. This relation actually give us the value of the velocity when you know the period. And this relation also be v is equal to 2 pi times f. If you know the frequency, you can also use this to find the velocity. So if you have frequency, you can use number 4, sorry. If you have period of the rotating object, then you can use number 3 equation to find the velocity. Read it.
Okay. Force on a revolving ball, horizontal. Estimate the force a person must exert on a string attached to a 0.150 kilogram ball to make the ball revolve in a horizontal circle of radius 0.600 meters. The
Okay,
ball,
can you tell me the data meanwhile?
okay. First, the mass is 0.150 kilogram.
0.150 kilogram. It means it has the specific unit. I don't need to change it.
Yep.
Okay, and the
Then
radius is
the radius is 0.600 meters.
0.600 meter. So I
That's
have radius, I have mass. Now what I need? Estimate the force.
estimate the ball makes two revolutions per second.
Okay,
T
we will write it if we require. I don't think so we require for force, because if you remember, for force, what was the expression?
F
F is
equal
equal
mv.
to F is equal to m
V
v
That's
square
square
over
over
R.
r.
oh, okay.
Okay, I found for centimeter. Now F is equal to mv square over r. Can you please help me to substitute the values? And
Okay,
please,
so F
everybody,
equal
I need you guys to solve with me. Use your calculators. So just substitute the values. M is
F
equal to
equal 0.5 kilogram.
0.150. Okay. V is,
Uh, I don't know.
oh, there is a problem.
Yeah, they
We
didn't give
don't
us.
have V. Okay, let me complete the data. What was given? 2 revolution per second. So they gave us time period. Either we can write frequency or we can write time period. So they gave us time period is half a second, 0.500 second. Okay, for finding the time period, for finding the velocity, you remember the expression was v is equal to 2 pi r over t. So let me find v first. So v is
Okay.
equal to 2 pi r over t. Just
Uh,
substitute the values for v first.
V
So we will
equal
find
2 pi
2 pi
0
times
100 over
r
0
is 0.6. Okay, over t
over
is
0.5.
0.5. Okay, give me the answer for v, please. 12
Yes.
over 5.
Mr. No,
Why?
Yes, sorry, pi.
Okay, keep it as it is, because I told you last time that the answer that is not actually asked by the question, we will keep it as it is. So we will search for the final answer. So write this value of v. This value of v in the expression. So 0.15 is m. V is
Okay,
12
then
pi
12
over 5 squared over r is
over
0.600. Okay, now substitute the values. What is f? When there is an object and this object has two forces. For example, this force is 5 Newton. I name it F1 is 5 Newton. And there is another force F2 on the other side. F2 is 2 Newton. So how I will find the net force? So you will use F1 plus F2. Actually, you will add them, but F2 is on the left side, so you will take it negative, and F1 is on the right side, you will take it positive. So you will write here 5 Newton plus negative 2 Newton. So in this way, your answer will be plus 3 Newton. Plus 3 Newton mean 3 Newton to
East.
right or east. Both are correct. Similarly, if I have this thing, there is a mass that is placed on the table. Its weight is, let's say, 90 Newton. Its weight. Its weight is 90 Newton, and someone is trying to pull with a force of the person that is upward, it's 100 Newton. So how much will be the net force? Net upward force will be 100 minus 90, or you can say 100 plus negative 90, both of same things. So it will be 10 Newton upward. So it will be upward force, that will be 10 Newton. But actually I'm trying to tell how to calculate the net force. This is also the review of the previous thing. Now I am getting back to join both of these explanations. This, the previous dynamics of circular motion, and this thing that I just try to show you how to calculate the net force. It's example number 5.4, and also there is a figure attached with it. So I will use this figure and I will try to solve it. There are two parts of this example.
A 0.150 kilogram ball on the end of a 1.10 meter long cord. Mr. What this? Negligible.
Negligible mass mean its mass can be neglected. It's zero. Mass of the cord is zero. Mass of the ball is given. So first given is what?
0 point.
No, mass of the ball is the first thing.
1.10. 1.10.
0.150.
Okay.
This is mass of the ball. Okay, what else is given?
Radius.
Yes, radius of the circle. Second thing is radius 1.10 meter.
Yeah.
Okay, now
Do I complete?
this you are not moving in this direction. You are moving like this, vertical loop.
Okay.
So this position 1 is at the top, and position 2 is bottom of the vertical loop. Okay.
Yeah.
Now read A.
Okay. Determine the minimum speed the ball must have at the top of its arc so that the ball continues moving in a circle.
Okay. We have been asked to find minimum speed. Thank you so much. In this figure, this is the top position. In the question they are saying at this position, what will be the minimum velocity? Before I go for finding the velocity, I just want to explain one thing. When you are moving this ball with the help of cord and your hand like this, you are moving this like this. As you increase your speed, as you increase the speed of the ball, you will feel that the string or the cord is applying more force, and your hand is feeling a force away from your hand. The string is applying that force away from your hand. So as the speed increasing, the string or the cord will be more taut. The string will be tightened, more tight. But if you reduce the speed, the tightness of the spring will be less. But if you keep on reducing the speed, there will be a moment when the speed will be too low, that when the ball will reach at maximum height, it will fall down. Yes or no? If you keep on reducing the speed, there will be one speed at which it will get down. Before that point, let's say that speed is 5 meters per second. So more than 5 meter per second, it continues in the circular path. Less than 5 meter per second, the tightness of the cord lose and it will fall down, it will not rotate. So the question says, find out that minimum velocity at which the ball keep on rotating in the circular path. So it means that string tension will be minimum at that point when the speed will be minimum. If speed is more, tension in the string, tightness in the string is more. Now this point you have to keep it in mind that if you are trying to find minimum speed, so this tension in the string will be minimum at that point. Now get back to the explanation part, get back to the solution part. Now we are on this page. We need to find minimum velocity, but before that, where we have to focus, we are not considered about the bottom point. They just ask for the top point. If you look at the top point, how many forces are acting at the top point, Mamoon? How many forces at the top point?
Sir, it's two, right?
Very good. Which are those two?
Gravity and the force of the string.
Very good. So how much will be net force?
They're the same position.
They are both toward the center. So net force will be tension in the string at top plus weight. Why I add them? Because both of these forces are in the same direction. As I explained you in the previous explanation, I told you that when both of the forces are in the same direction, we will add them. Both in opposite direction, we will subtract them. Now, this is the net force. This net force is actually the force that keeps the object moving in the circular path. So the force that keep the object in the circular path, what we call it? The force that keep the object into circular path, what we call it?
Mr. Centripetal actually.
Centripetal. So we call it centripetal force. So I will write this F net is equal to FC is equal to FT1 plus mg. One more thing, please. What is value of FC? M V square over R. I just explained you a moment ago that when this object is rotating, it has a centripetal force. When it reaches at the top position, if the velocity is minimum, it will be, the tension will be minimum. If velocity is maximum, tension will be more. Maximum. So this tension we need to find for minimum velocity. We need to find for minimum velocity. So can I use for minimum velocity, the force of tension in the string is approximated to 0, because I told you if the velocity is minimum, the tension in the string will be minimum, and if we reduce that velocity after that point, it will fall down. It will not keep in circular path. So I will consider that this tension in the string is 0. So put 0 here, or don't need to put it here, only write mg. Now the question is find the minimum velocity. So I can write this velocity as v minimum. Why? Because I put the tension 0 when velocity is minimum. As velocity is minimum, so we can say that velocity is minimum, tension is 0. Now, can you simplify this relation with me? This R is divided here. On the other side, it will be multiplied, and M is multiplied to V. It will be
and then divide by M, right?
Yes. So V square is mg times R over M. So this M, can I cancel it?
Yes, we can cancel it.
It's M and M. Now I need to find the expression for V. What will be that expression?
9.8.
No, V. This is V square.
Yeah.
So V will be equal to
G
root of Root of G multiplied by R. Yes?
Yeah.
Just substitute the values.
9.8 multiply 0.150.
Can you please solve it for me?
Yes, 1 second.
9.8 times R is, how much is R?
0.150, right?
1.10.
1.1. I forgot.
1.10. So minimum velocity that is required at the top position is how much?
3.28 or 3.3.
You find out the root also.
Yeah.
Plus minus 3.28
3.
meter per second. In part B, it is said, calculate the tension in the cord at the bottom. This is your bottom point, this one.
Okay.
Now they are asking you to find tension in the string. So again, you have to develop the relation, but let us write the values they ask. Calculate the tension. So you have to find Ft2. This is first thing that you need to find. Secondly, assuming the ball is moving with twice the speed. So what was the speed? It was 3.28. At the bottom, its speed is 2 times the minimum speed. Why I am multiplying by 2? Because they are asking that at this point the
Twice.
velocity is 2 times. So it was 3.28. When you multiply, what is your answer?
6.56.
3. Yeah.
6.56 meter per second. I need net force, and for net force, will I add Ft2 with mg or subtract? Okay, I will subtract Ft2 minus mg. Now again, what is this net force? This net force is the centripetal force because the ball is moving around the circle. So I will change this F net into Fc is equal to Ft2 minus
mg.
Now I need to find this Ft2. So mg will be on the other side. So what will be the expression?
Fc plus
Fc plus mg. So do you remember the value of Fc? mv square over r plus mg. Now just substitute the values and give me the value of Ft2. 0.150 into what is V? V is this one.
V 6.6
because we are talking about at the bottom. So this is 6.56 squared over R is
the radius was 0.1.10. 1.10.
It was 1.10 or 0.1.
I don't know.
It is 1.10. Yes. Now
So,
plus mg
wait.
plus 0.15 times 9.8. So the final answer is 7.338. But this is having 4 significant figure. When you will convert it to 3,
it will be 7.34.
Very good. Ft2 is 7.34 newtons. So this is your answer for the 10. I want you guys to answer this question. There is a rider on the Ferris wheel. He is enjoying, and I know you also enjoy when you go to Playland and you used to sit on these kind of Ferris wheels. And it is moving in a vertical circle of radius r at constant speed. Speed is not changing. Is the normal force that seat exert on the rider. You know, when you are sitting on the seat, weight is acting downward, the normal reaction of the seat is upward. So they are saying, is the normal force that seat exert on the rider at the top of the wheel less than, more than, or same as the force exerted at the bottom? This normal force at the top is more, less, or equal to this normal force at the bottom. What will you say? Where normal force is top is more or bottom is more? As it's going down, the force increases. So more force is at the bottom as compared to top. So your answer is response A. At the top, it is less than the bottom. Thank you so much, guys, for your participation.